Hi, welcome to Turn Right Machine Works. My name is Keith. Today I have a new project here, and this is probably going to start a new style of gig here in the shop. This is the second job. Of course, this one here was mailed. The other job I did there with the flat belt pulley was brought in by Joshua, but Nathan from Arizona contacted me through email, and it basically started all out like this, and it says, I have a shaft out of a Benchmaster punch press I need redone. I have pictures that I attached that show the problem on the shaft. It appears it spun and severed a key and someone welded it. I would like the shaft new and the cam that is welded on to be made new. And so I looked at the pictures, and and he kind of wanted a ballpark idea, and I figured it was like 4 or 5 hours to go ahead and make the shaft and the cam and the type of fixture. Over looking at photos and everything else, sometimes you don't really know what it's going to be. I'm just trying to be fair, and also too, those two, I kind of looked at some material, and I figured 4130 would be a good material. It takes impacts and stuff like that. It'd be good for rotating units on a press. It's just kind of my feeling. So anyway, the box arrived the other day, and we have this project here. So come on in and take a look at it. Okay, basically we're looking at, this is the only thing I could get on the internet here, and this is a Benchmaster 5-ton press. And basically it just gives you the bare minimum accessories and things like that you can spend more money on getting it up on the stand, and the 2-palm controller and all of that kind of things. And it gives you a couple features, but that's it. Options, specifications, blah blah blah. Alright, now this is a little bit smaller. One thing that it does have on here, and this shaft is 1 1/8" diameter on the 5-ton press. Now this is a 3/4 inch, and I believe he said this is a 1-ton punch press. Now my question out there for you guys that have Benchmaster punch presses is the fact that these spot welds that seem to be real uniform on each side holding that cam on, is that a weldment, a stock operated setup? There's definitely plenty of room here where these bearings have ride, and this is my inspection of this unit. This is what I'm looking at. If it was a regular hack and tack welding, I don't think that these would be equal on each side. It would probably be easy access or whatever. I don't think somebody would have really thought that out, and I think and I do welding on shafts all the time, and if you're equal straight across from each other, you can really control warpage and stuff like that. Now this little tack welding that's on the backside here is holding a little round disc with a pin that guides a spring, and this is a little mechanism here for shifting the engagement and tripping out for the cycle. It makes one cycle on a punch press here at a time, and you can see how they made this groove. They drilled a hole, and then they broached out the square shape for this to fit in there, and then they create a little round disc with that little pin offset on there, and it sets in a little tiny recess in there, and that's welded. Okay, we're going to go ahead and tag up a few things here so we can start disassembling this, and we're going to get it up on rollers, and we're going to roll this thing and actually see how much run out is in the shaft to help us determine whether the welding was standard, or you know what, too, it could really be a very talented repair. I've made a few myself. Alright, we're going to call this end here the drive end, and we're going to call this end thrust end. How come every time I come in here and use this, that air compressor comes on? The Murphy's Law, right? Okay, socket, just going over that little Zerk fitting. Alright, and she's not on there real hard. Alright. And she's got a dimple location right there. We know how, you know, you can't mess that up getting that on there. So we're gonna go ahead and get that tag, and we'll take a look at that. We're gonna pull that key out, pull that bushing off. Now we have a Woodruff key in here, and instead of banging and tapping and beating on the key, one of the first things I usually try, and this is just because Bridgeport vise is really nice to do this, and I don't know how tight this is in here, but you can get a hold of your key with a good grip, and then you can use the rocking of the shaft to go ahead and pop out your Woodruff key. There we go. Okay, and the Woodruff key looks pretty good on both sides. It's not like it moved around or rocked or has any wear on it. We're going to keep it with that little trigger mechanism right there, and we can slide off our next bushing. Alright, there's all of our items off of here, and now we have a shaft here. Alright, and I think we're going to go ahead and we're going to go in and we're going to wire wheel all the little rust and corrosion and everything else off of this thing here. And we're going to come in and we're going to set it in on the rollers. Alright, we got it wire wheeled and clean, and you know, I had asked Nathan if he thought the tacks were factory or not, and he said he saw a crack, and I actually think I see a crack right in there too, and I see one like right there. We'll throw some dye in here and we'll check those real quick. Alright, but you know, not necessarily that we even need to dye check it. I can see over here, and I don't think that these marks right here are stock. Okay, I think those were added after the fact, and to actually have a dent right there without no mark on the shaft right there, this thing was off and somebody beat it. Beat it. Okay, so anyway, alright, let's put it on the rollers and let's see how she rolls as far as trueness here. And we just want, I'm going to try to hold it as still as possible. It's kind of hard with the counterweight on here wanting to go. That's a flat right here where somebody ground a little bit oil clearance there. Okay, so we can't count that, but it's either side is like -3 and then it goes back up to 0. So we do have some run out there. And let's just turn it around, dummy. Okay, we're getting a couple thousandths there. So we do have run out in the shaft. Well, I don't see any definite cracks. I see a couple porosity holes right there. A crack would be showing up like that right there. That line where the two parts join together. Alright, but those custom marks right there tell me that this thing has been beat on before. And I'm going to set it up and cut those welds out. We got 3/1000 run on this shaft here, and I want to really get it out there. We're going to get a scale here, and we're going to take some end-to-end measurements so we know exactly where this hub lines up there. I see some dye in there, and I see some scrapes over there. Oh. Really is kind of hard to tell if it was, I mean, it took a little bit of pressure to press it off, but not a whole bunch. We're going to snap gauge that bore and mic this right here. We'll see what we have for interference. Let's snap it in another couple places here, just to make sure we're getting an even reading there. $7.50 right on the money. This is miking out at $7.50 right on the money. I don't know if the weld was stock or not. The diameter didn't seem, you know, I would think this thing would be a press fit of at least 1,000, and I didn't find that in the bore. The hammer marks right here were probably done to squeeze this in, and that didn't work, and it had travel on it, was causing problem, and they probably welded it. There's also some grinder marks on this low side right here. Hard to say what that is. And we got at least a good sample here to go by to make a new shaft. Alright, we got a new bar and we're going to make that out of. And we got a, you can only buy a foot of this, so it's not like I can buy a couple inches of it, but that's going to be the diameter of the round. Alright, let's go pull this key out. Well, I'll get a little cleanup on this tomorrow, and we'll get a look at that. It really looks like that pin and this, without the tag and everything else, I checked out the motion and stuff like that. It's like a dead ringer, like it's supposed to be. You know, if it was made brand new, that could have been silver soldered in or whatever. I'm going to see if I can flush that out just so that it's not any high spots. I don't see anything else that would be wrong with this. If that was the only thing you were marking up there, Nathan, and looking at it, as long as it doesn't pop out, that's the only thing we got to make sure it doesn't pop out. Alright, couple different ways we can go. I'm going to look at maybe an undersized ringer, keeping everything all one size, and that could have been traveling around on them, being exactly the same size, if not just a skosh under, you know. And the run out, you know, you can see where it was wearing on one side, not on the other side there. So I think your suspicions were right that somebody had to weld that, and in doing so it caused a little warpage. The back side of this is not real smooth, so I'm glad you sent the bearing. We're going to go ahead and pick up a diameter on this, and we'll start making the new parts. We'll get you squared away. All right, it's enough for tonight. Get her done.